The chain rule is one of the most important rules we have for finding derivatives because it helps us find the derivatives of compositions. And you should recall that a composition, oh goodness, look what I'm doing here. Let's try that again. A composition would be something like f of g of x, where we plug in, oh, hold on a minute. We plug g of x into f of x, and here's what that looks like. As you can tell, I'm still not great at drawing on this thing, but bear with me here. If we want to take the derivative of this composition, indicated by that little apostrophe, the chain rule says take the derivative of the outside function f with g of x plugged in and multiply that by the derivative of the inside function g of x. And if you have more than two functions composed, then you'd continue to chain those together, starting at the outside and working your way in. When you write the chain rule this way, it's a little intimidating because you have all these grouping symbols, and so one of the ways that we also write this rule is with Liveness notation. It looks something like this. Let's say we have a function y equals f of u, where u is the function that we've plugged into f, and then u is some other function itself, g of x. And with Liveness notation, we would write dy over dx equals dy du times du dx. And if you're familiar with how fractions work, when you multiply them, you can kind of see how, in a way, these du's cancel and we end up with dy dx. So the simplifying seems to make sense here. What might help is if I show you an example of the chain rule in action. So I happen to pick out a problem from page 189, number 11. You'll see that here. The problem says find the derivative of f of x, and f of x is this function, which is the square root of 3x minus 2. Well, we can write this function as a composition. I think you can see without too much trouble that we've plugged the function 3x minus 2 into this other function, which is a square root. And so our strategy on this is to do what we call u substitution. And so what that means is the inside function I'm going to rename as just u. So this whole thing will be called u. That means that my function y equals f of x is actually the square root of u. So what we do then is we write down what we said u was. We're going to substitute u into the original function. So our function y, or f of x, is actually equal to the square root of u. Okay? And then to implement the chain rule, what we do is we figure out the derivative of each of these. So the derivative of u, which we'll call u prime, that's just 3. And then the derivative of y, which we'll call y prime, that's going to be whatever you get when you do the derivative of the square root of u. Now, it may help us if we write this with an exponent, right? U to the 1/2. The derivative is 1/2 u to the negative 1/2. And then that simplifies, I guess if you want to call it that, to 1 over 2 square root of u. Now we have these two derivatives, the 3 and the 1 over the 2 square roots of u. And then the chain rule says we need to multiply these together. So my final derivative, which we're going to call f prime of x, is going to equal 3 times 1 over 2 square root of u, which is 3 over 2 square root of u. Here's the problem. We're not really supposed to have u in a function that's supposed to be defined in terms of x. So one final substitution is going to be that we're going to take this 3x plus 2 and put it back where u is located. So my final derivative, written in terms of x, is f prime of x equals 3 over 2 square root of 3x minus 2. Got to make that fraction bar bigger there. And so this is the derivative function for f. The original function was the square root of 3x minus 2. The derivative is 3 over 2 square root of x minus 2. Well, I hope that explained it a little better. Good luck with the chain rule.